Good day, everyone. Today we're going to be talking about the second part of 4.3, okay, where we're transforming the absolute value parent function. In yesterday's lesson in class and in yesterday's ed puzzle, we talked about how this is the parent function. It looks like this V-shaped figure. That's an absolute value graph. And we also talked about how we can actually shift it using addition on the outside, or addition and subtraction on the outside, as well as addition and subtraction on the inside. So we came up with this equation of the inside value makes go left and right, and the outside value, or C here, makes go up or down. And every single graph can relate back to that function. Well, today we're going to talk about two other types of graphs, okay? In today's lesson, we're really going to focus on looking at as these different types right here, which, if you notice, are basically going to be if I multiply a value on the outside, like this 3 is right here, or if I have a negative value on the outside. And basically, we're just going to try to analyze what actually happens when I do that, okay? Well, for this case, I'm actually going to work through and try to think what's happening right now with the 3, okay? For example, if I take my chart here and use the same numbers we talked about yesterday, -2, -1, 0, 1, and 2. For this graph right here, I want to know basically what's going to happen, because in the original graph, basically all the numbers stayed the same, however they became positive. So now, what's going to happen if I multiply that 3 to it? Well, here's where the key thing comes into play. If I were to plug this value of 2, -2, into that absolute value, it'd become a positive 2. But then I'd have to multiply the 3 to it to get 6. So if you notice, I went from -2 to a positive 6 because the negative would become a positive because of the absolute value, and then I'd multiply by the 3. The 1 would become a 3, but the interesting thing is if I plug 0 in for x, no matter what, anything times 0 is just going to stay 0. The 1 becomes a 3, and the 2 becomes a 6. So you notice this pattern here of basically multiplying by 3 and just making the value positive kind of exists. This is where the first important concept comes into play. Notice how this graph goes up 1 over 1 each time. Okay, on both sides of the graph, it goes up 1 over 1. Okay, kind of like how we used to talk about slope, how it goes up 1 over, left and right. Okay, well, for our new graph, now we're not going up 1 over 1, we're going up by 3s. So even though my original coordinate's going to stay the same right on the origin, my new one's going to go up 3 units and be on the right and left-hand side, and now look like this. Okay? This is what we call a stretch. Because what it's doing is it's stretching my point. Instead of the point being here, it stretches it up to there. Instead of the point being here, it stretches it up to there. Okay? And anytime you have a multiplier on the outside, it's going to cause this. On top of that, on the graph to the right, now we have a negative value. Well, all a negative really does is flip your graph, which basically means is that this graph is pointing up. Well, if I throw a negative in front of it, it's just going to flip it so it goes upside down. We call this a reflection. Okay? So what we want to do is we want to build an equation basically stating all of this information so that we have it in front of us. Okay? If I were to go all the way over to these problems, we're going to start to get into problems where I have to basically label out everything that's going on. Okay, just like the try these A. Well, currently we have the equation y equals negative a x minus b plus c. And each one of these things besides the x does something. The negative causes a reflection. The a value causes a stretch, or the one we haven't seen yet is a shrink. That's when you have a fraction. The b value is left and right, and that one is always opposite. And then c, my last one that I have to talk about, causes it to go up or down. And just by using these four pieces, I can pretty much graph or state everything that's going to happen within a function. Okay, so for try these A, they really just want us to describe what's happening in each of these. Well, if I look at this function, I see a reflection because of the negative. So we have a reflection. The negative one on the inside, so our -1 value here, because it's inside the absolute value and it's negative, is going to make it go right 1 unit. And now the last one is this +2 on the outside. Because it's adding 2 on the outside, it's going to make it go up 2. And just like that, I can describe everything that's going to happen to that graph just based off those three values. In letter B, it's the same idea. The 4 in front is going to cause a stretch. So we have a stretch of 4. The net +1 on the inside, because it's positive, I have to do the opposite. So it's left 1 unit. And last but not least, we have a -3 on the outside, which is just going to make it go down 3. And just like that, I can label out all my transformations and basically state them in this problem. And it's just easy as that. We're going to be using this equation constantly throughout this section and other sections, okay, where I'm dealing with transformations. Okay, these transformations will always stay the same. They'll always apply these same ideas. So it's important to early on get to know these and understand them, where they're at, what position they're at, and everything like that. Because as we move forward, if you get them now, the other sections are very easy. So now, this is the last part I want to talk about. We're just going to talk about letter C because we want to basically describe what's happening in this graph. We want to basically say, what's the equation? So we got to think y equals a x minus b plus c. So we want to think, is there anything happening in all three of these? Well, first off, understand that anytime I get a problem like this, we start at this coordinate. Okay, that's the coordinate we're actually starting at. So first and foremost, I want to know, how did I go from there to here? Well, if I count this out, I went right 2 and down 1, 2, 3, 4. So right off the bat, I know this is right 2 down 4. Okay, if the original is supposed to sit at the origin, the new point is moved right 2 down 4 from that original point. Next, let's count our slope. Usually this coordinate is supposed to go up 1 over 1, and I get to my next coordinate. Well, if I count this out, this goes up 1, 2 over 1. Oops, excuse me, 1, 2, 3 over 1. Notice how every time I go up 3 units, I get to another spot where it crosses. That's another important part because that's going to tell us where our stretch is. Because I don't get to a clean location until 3 units up, that tells us we have a stretch of 3. And there is no reflection here because the graph is facing upwards. So if I go ahead and plug these values in, this says y equals, A is our stretch or shrink. We went right 2, so I want to do -2, because remember it's always opposite. And then since I went down 4, on the outside, I need to subtract 4. And I have the equation built for that problem. Okay. No, this is kind of the whole purpose of today's lesson is we're literally not doing any math. We're not solving anything out. We're not actually applying anything. We're really just dealing with this idea of these transformations can be used in a problem. Okay. I can come up with an equation using them, or I can actually graph a problem out using them. Okay. And that's kind of the first important thing to take in. Besides that, though, feel free to answer the questions, and I will see you in class tomorrow. Have a great day.